Today we will see how to integrate sine nth power x dx without using integrations by parts, which means without even using the reduction formula. When we do not use the reduction formula or integrations by parts, we have to first pay attention on this power n. Depending on whether n is an even integer or an odd integer, we have a unique approach for each case. During our previous video, we completely discussed the case where n is an odd integer. In fact, you are required to know how to integrate sine nth power x dx when n is an odd integer in order to understand the discussion today. Today we are going to look at the case where n is an even integer. When we learn this process, as a part of this integration, you will happen to apply your knowledge on integration of sine nth power x dx when n is an odd integer. Well, it may not necessarily be for sine odd powers. It may also be for cosine odd powers. Whether it is sine or cosine, the process stays the same for any odd power. Alright, now we will directly go into the instructions on how to integrate sine nth power x dx when this n is an even integer. When n is an even integer, we can write down this given integral as integration sine squared x raised to the n over 2 power dx. Since this n is an even integer, you have to understand that n over 2 is also a positive integer. Alright, after writing it down that way, we are going to convert the sine squared x term into a first order cosine term. We can do that using the cosine 2x expansion. We know cosine 2x is equal to 1 minus 2 sine squared x. This is one of the three expansions available for cosine double angles. From this identity, we can subject sine squared x. Sine squared x will be equal to 1 minus cosine 2x all divided by 2. Now, what we are going to do is sine squared x term right here will be replaced by all of these things, 1 minus cosine 2x over 2. And then we have to raise this function 1 minus cosine 2x all divided by 2 to the power n over 2. And then we have to integrate that function. Alright, now we will directly go into an example. Let's say we need to integrate sine 6th power x dx. Since this power 6 is an even integer, we can write it as integral sine squared x, all that raised to the 3rd power dx. And after that, we are going to replace the sine squared x using sine squared x equals 1 minus cosine 2x all divided by 2. Alright, when we do that, this integral becomes equal to integration 1 minus cosine 2x all divided by 2 raised to the 3rd power dx. Now I can do some simplifications. This 2 is raised to the 3rd power, which is equal to 8, and that 8 is in the denominator, which I can write outside of the integral in the denominator as a 1/8. Integration 1 minus cosine 2x, everything raised to the 3rd power dx. Alright, and then what? You can easily expand that if you remember how to expand a minus b raised to the 3rd power. A minus b raised to the 3rd power is equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. We can use that identity and expand 1 minus cosine 2x raised to the 3rd power by taking a equals 1 and b equals cosine 2x. Then this integral becomes 1/8 integration, I will open parenthesis, 1 raised to the 3rd power, which is equal to 1, minus 3 times 1 raised to the 2nd power times cosine 2x plus 3 times 1 times cosine 2x raised to the 2nd power, which is cosine squared 2x minus cosine 2x raised to the 3rd power, which is cosine cubed 2x. I will close the parenthesis and dx. All right. Now, when we look at this integration, we can easily integrate 1. Also, we can easily integrate cosine 2x. But we have a cosine squared 2x term and also a cosine cubed 2x term. Cosine squared 2x term can be converted into a cosine first order term. That can be done using the double angle identities once again. We know that cosine 4x should be equal to 2 cosine squared 2x minus 1. That's according to the double angle identities. Now from that we can subject cosine squared 2x. It will be equal to 1 plus cosine 4x all divided by 2. That way we can convert this squared term right here into a first order cosine term. And still we will have cosine cubed 2x as a remaining term. To integrate that, you will need the knowledge from integrating sine or cosine functions raised to odd powers, because this power right here is a 3. Alright, we will do it later. For now, I'm going to just replace this cosine squared 2x term with 1 plus cosine 4x divided by 2. Therefore, this integral becomes 1/8 integration within parenthesis 1 minus 3 cosine 2x plus we have a 3 right here, 3, and we said cosine squared 2x term is equal to 1 plus cosine 4x divided by 2, and then minus cosine cubed 2x. I will close the parenthesis and we have dx. Now we can combine the like terms. I have a 1 right here and I have 3 halves right here. So we can combine those two and write down this integral as this is equal to 1/8 integration 1 plus 3 halves is equal to 5 halves. And then I have minus 3 cosine 2x, and then I have 3 cosine 4x over 2 and minus cosine cubed 2x dx. Next, we can see that all of these terms can be quite easily integrated. Therefore, I'm going to consider all of these things as one integration and this one as a separate integration. I'm going to label this last one as integration j. Alright, now I will go ahead and integrate this part because we already know that part, and then we can separately integrate our integral j. We have a 1/8. When we integrate this first term right here, 5 halves, we get 5x over 2, and then we have minus 3 cosine 2x. It will become minus 3 integration of cosine 2x is equal to sine 2x over 2. Therefore, this term becomes negative 3 sine 2x divided by 2. Alright, and then we have 3 halves times integration cosine 4x. It will become plus 3 halves times integration of cosine 4x is sine 4x over 4. Alright, that is this first part of the integral we had earlier. And then in addition to that, we have minus integral j. We will evaluate integral j separately and come back here and substitute that answer for j. Alright, now it's time to evaluate the integral j. J is equal to integration cosine cubed 2x dx. This is an odd power. How did we integrate odd powers? We split odd power into integration cosine squared 2x times cosine 2x dx. And then what? According to our previous video's explanation, we need to write down cosine squared 2x as 1 minus sine squared 2x. That is according to the Pythagorean identity. And then we need to multiply cosine 2x into each of these two terms inside the parenthesis. Alright, when we do that, we get integration cosine 2x times 1 is just cosine 2x dx, and then we have this negative symbol minus integration sine squared 2x times cosine 2x dx. Alright, now what? Of course, we can quite easily integrate cosine 2x dx. But how would you integrate sine squared 2x times cosine 2x? We can apply the integration f of x raised to the nth power times f prime x dx, where f prime x is the first derivative of f of x. In this case, we know this is going to be equal to f of x raised to the n plus first power divided by n plus 1. This theorem is applicable for all the cases except for the case where n is equal to negative 1. Alright, now to apply this theorem, I can identify sine 2x as my f of x. I can identify 2 as the power n. And then I need f prime x, which is the derivative of sine 2x. We know the derivative of sine 2x is equal to cosine 2x times 2. What I don't have is just times 2 term. I can write a times 2 somewhere here, and then I can divide that out by writing a 1/2 outside. Now for this integral, I can directly apply the theorem right here. Therefore, our integration j is now equal to the first term. Cosine 2x integration is sine 2x divided by 2. And then minus, we have a 1/2 right here. I will write that down first. Integration sine squared 2x times cosine 2x times 2, for which we are going to apply this theorem right here. On the right hand side, it will be equal to f of x raised to the n plus 1 over n plus 1. F of x is sine 2x, n is equal to 2, n plus 1 is equal to 3. Therefore, this is going to be sine cubed 2x divided by 3. Now we can simplify this some more and write j as equal to sine 2x over 2 minus sine cubed 2x over 6. Now we can go ahead and replace this j in the partially solved integral earlier. We had sine 6th power x dx equal to 1/8 bracket 5x over 2 minus 3 times sine 2x over 2 plus 3 times sine 4x over 8 minus j. What we just now evaluated is this j. So we can go ahead and replace that value and write down our final answer. Our final answer will be therefore equal to 1/8 bracket 5x over 2 minus 3 sine 2x over 2 plus 3 sine 4x over 8, and we have minus j. Therefore, it will become minus sine 2x over 2 plus sine cubed 2x over 6, close the bracket, and of course there will be a plus c. That's our final answer for this example. If you would like to practice this method some more, I would like to give you a homework question. Here is the homework question. Integrate sine 8th power x dx. Of course, this power right here is equal to 8, which is an even power. That means we are going to write this as sine squared raised to the 4th power. In that case, sine squared x will be replaced by 1 minus cosine squared x. When you write 1 minus cosine squared x raised to the 4th power, the next step is to expand that term. That expansion will be easy if you can remember how to expand a minus b raised to the 4th power. A minus b raised to the 4th power has these coefficients: a to the 4th power minus 4a cubed b plus 6a squared b squared minus 4a b cubed plus b raised to the 4th power. Alright, with that little help, I hope you will be able to completely solve this problem, integration sine 8th power x dx. I hope you enjoyed this video. Thank you so much.